Hi guys, and welcome to our first video lesson of fourth quarter. This is going to be one of two videos you guys are going to watch for your lesson tomorrow. The first thing we're going to start doing is finding the six trigonometric functions of any acute angle theta in a right triangle. You guys might be wondering how we have six trig functions because maybe you only remember three of them. So if we look at this area right here, the top three should look pretty familiar. We have sine theta, cosine theta, and tangent theta. If you want me to write those real names, sine is S-I-N-E, cosine is C-O-S-I-N-E, and tangent is T-A-N-G-E-N-T. But we abbreviate them with S-I-N, C-O-S, and T-A-N. Okay, we have three new trig functions, which are actually the reciprocals of these three that we already know. This one, abbreviated CSC, is called the cosecant. So if we look down here, the cosecant is the reciprocal of the sine function. And you can see that instead of the sine that's opposite over hypotenuse, we have hypotenuse over opposite. The second one is secant, S-E-C of theta. That's down here. That's the reciprocal of the cosine function. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And finally, cotangent is the reciprocal of the tangent. So we would just flip those sides to make it adjacent over opposite. So basically, if we want to find all six of these functions, we just have to find the sine, cosine, and tangent, and then flip those ratios. So let's get started. Example 1, find the values of the six trig functions of theta. First of all, in order to find all of these values, we need to know every side length in the triangle. This triangle gives us one leg of 3 and one leg of 4. From our angle theta, 4 is our opposite side because it is across the triangle, and 3 is our adjacent side. The hypotenuse is labeled for you as hypotenuse. It won't always be. Remember, that's across from your right angle. However, we do not know the length of the hypotenuse, so we'll use the Pythagorean theorem to figure that out. So Pythagorean theorem, we're going to take a squared, which we'll say 3 squared, plus b squared. 4 squared equals our hypotenuse squared, c squared. So that's 9 plus 16 equals c squared. 25 equals c squared, thus c must be 5. Okay, so now that we know each side length, we can go through and do all six trig ratios from the angle theta. Let's start with sine, cosine, and tangent. Okay, remember that the sine of theta is the opposite over the hypotenuse. So from our angle theta, we are going to put 4 over 5. The cosine is adjacent over hypotenuse, so that will be 3 over 5. And the tangent is opposite over adjacent, so that is going to be 4 over 3. Now, the next three, remember, are the reciprocals of these three. The reciprocal of sine is cosecant, which we use CSC. So CSC theta equals 5 over 4. The reciprocal of cosine is secant, so we use SEC. SEC of theta, and we flip the cosine. That's 5 over 3. And finally, the reciprocal of tangent is cotangent. So we're going to flip the tangent, and the cotangent of theta will be 3 over 4. All right, you found out 6 of them. Let's go to triangle B. We see angle theta there in the bottom left-hand quarter. We see that 2 is opposite of that. We also see that the length 4 is across from our right angle, so this is our hypotenuse. We are missing the length of the adjacent side, so we are going to have to use the Pythagorean theorem to find that. Now, because we know one leg and the hypotenuse, it's going to look a little different. We'll have 2 squared plus b squared equals 4 squared. So 2 squared is 4, plus b squared equals 4 squared, 16. Subtract 4, b squared equals 12. Okay, when I take the square root, I am going to get b equals the square root of 12. Now, one thing with these, I'm always going to ask you to express your answers in reduced radical form. So remember what we do. We say, are there any perfect squares that go into 12? And sure enough, 4 times 3 gives us 12. So we could write this as 2 times the square root of 3. So that is what we will be using for that side length. All right, let's start. Let's do our sine, cosine, and our tangent. Let me change colors. So sine of theta is opposite over hypotenuse. Opposite is 2, hypotenuse is 4. I hope you guys know we don't want to leave it like that. That's not simplified or reduced, so we should have 1/2. Okay, that will be our final answer. Cosine of theta is adjacent over hypotenuse, so 2 rad 3 over 4. We also can reduce that and leave the 2 on the bottom. So this is going to be rad 3 over 2. And finally, tangent of theta, opposite 2 over adjacent 2 rad 3. Well, your 2's cancel, and that leaves us with 1 over rad 3. And then remembering we don't leave radicals in the denominator. We are going to rationalize by multiplying by rad 3 over rad 3. We get rad 3 over 3. Okay, let's do the reciprocal functions. Let's start with cosecant. Remember, cosecant is the reciprocal of sine. So I'm going to look up here, and I'm going to flip that. That would be just, well, you could do 2 over 1, but we'd never leave it like that. That's just going to be 2. Secant of theta is the reciprocal of cosine. So that's going to be 2 over rad 3. But that's a big no-no. We do not want a radical in the denominator. So let's multiply by rad 3 over rad 3. So 2 rad 3 over 3 is the secant of theta. And finally, cotangent of theta is the reciprocal of tangent. The easiest place to do the reciprocal is actually right here before we multiplied, before we rationalized, because if I flip that 1 over rad 3, that's going to be rad 3 over 1, which is just rad 3. Okay, guys, we are going to do letter C, and then these 2 on your own problems in class. I hope you enjoy the next video.